How is actigraphy data analyzed? Have you ever wondered how scientists and health professionals analyze sleep patterns? Actigraphy is a fascinating tool that helps us understand our sleep wellness. Let's break down how actigraphy data is analyzed step by step. First off, actigraphy starts with a device worn on the wrist called an actigraph. This small gadget contains an accelerometer that continuously records movement over several days or weeks. The data collected consists of activity counts, which show how often and intensely a person moves. Once the data is collected, the first step in analysis is data preprocessing. This means cleaning the raw activity counts to prepare them for interpretation. Analysts remove any artifacts, which are inaccuracies in the data, and periods when the device was not worn. Next, sleep scoring algorithms come into play. These specialized algorithms interpret the movement data to distinguish between sleep and wake states. They use specific thresholds of movement to determine when a person is likely asleep, indicated by low or no movement, versus awake, marked by higher movement levels. Different scoring methods can be used, and the choice of method can influence the results. After scoring, analysts define sleep periods. This includes identifying critical time intervals like time in bed and sleep period. Time in bed is the total time spent in bed trying to sleep, while sleep period is the actual sleep duration. The start and end points of these intervals are determined based on movement patterns and sometimes sleep diaries. From the scored data, various sleep parameters are derived. Total sleep time is the actual amount of sleep during the sleep period. Sleep onset latency is the time it takes to transition from wakefulness to sleep. Wake after sleep onset is the total time spent awake after initially falling asleep. Sleep efficiency is calculated as the percentage of time in bed spent asleep. Analysts also look at the number and duration of awakenings during the night. To make sense of this data, visualization is key. The data is often presented graphically, showing activity plotted over time. High bars indicate wakefulness and movement, while low or flat bars indicate sleep. Finally, sleep specialists or researchers interpret these parameters to assess sleep quality, patterns, and potential disorders. They may compare data across different nights or individuals to identify trends or abnormalities. From the perspective of sleep wellness, actigraphy analysis offers a practical and non-invasive way to monitor sleep patterns in natural environments over extended periods. This helps individuals and clinicians understand habitual sleep behaviors, identify disruptions, and evaluate the effectiveness of interventions aimed at improving sleep health. Tracking sleep in daily life supports personalized strategies for enhancing sleep quality, which is essential for overall physical and mental well-being. While actigraphy relies on movement as a proxy for sleep, it may not capture all aspects of sleep architecture that more complex methods like polysomnography do. However, its ease of use and ability to monitor sleep continuously make it a helpful tool for promoting sleep wellness through ongoing assessment and feedback.